Hi everyone, in this lesson we'll be working on lesson number 33, Systems of Inequalities Graphically. We are on page 37 in your Unit 3 packet if you are in Ms. Drake's class. Your first job is going to be to work on the do now, and then you can pause the video, check your answer on the answer key, and then we're going to move on to Systems of Inequalities. Okay, so a system of inequalities really just means two or more inequalities with the same variables. So we're going to fill in the blanks here. Two or more inequalities with the same variables is called a system of inequalities. The set of all ordered pairs that make both inequalities true is called the solution set for the system of inequalities. The solution set is represented by the overlap or intersection of the two shaded areas. We have a picture right here of a system of inequalities. It's this inequality, y is less than 2x minus 3, and 2x plus y is greater than 2. You can't see it great because this picture is black and white, so let me pull up the lesson and what it's supposed to look like. This was the original picture before we made photocopies. You can see it a little bit better. So we have two inequalities. So we have the blue dashed line, which represents this inequality, and the blue shading. And then we have the yellow region and the red line, dashed line, which represents this inequality. So what we're really looking for is the overlap. So where the blue and the yellow overlap, you see this green section right here. So this whole green area, or the double shaded region, is considered the solution. When we start creating our own graphs, so this, if on your page, you should shade in. So this double shaded region is considered the solution set. When we start creating these in class, you will label the whole area with a big S. S stands for solution. Okay, so anything in that region would be a solution. So any point here, 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 as long as it's not on a dashed line on the border. Okay, so let's turn the page. So we're going to skip over example 1 and take a look at example 2. Again, this isn't in a system of inequalities that is done for you. I'm going to pull the lesson up again so you can see the colorful picture. Okay, so we're really looking at this system right here. We have the blue line and the blue shaded area, and then the red dashed line and the red shaded area. So this double shaded region here is our solution set. Okay, so on your page, I'm going to put a big S for solution. So anything in that region is considered a solution. Now, if it's on the border, on a solid line, it would be considered a solution. But if it's on the border on a dashed line, it will not. So we are going to be proving a few different points, whether they are solutions or not, algebraically. So this has an equal sign. Let's change this to y is, we're talking about this line right here, so we're shaded underneath, and it's a solid line. So what type of symbol would you have? Hopefully you said less than or equal to. So y is less than or equal to negative x plus 4. Now this equation has to do with this dashed line and the shading above. So what symbol would you replace the equal sign with? So dashed line and shaded above. Hopefully a greater than symbol. So we want to prove that this ordered pair is a solution to the system. That means it has to be true for both inequalities at the same time. So first I'm going to plug into the first inequality. So y, I'll replace with 4. So is 4 less than or equal to negative x? So I'll replace the x with a negative 3, and then plus 4. So I want to prove that this is true. So 4 is less than or equal to, the negative of negative 3 is 3, plus 4 is 7. Is 4 less than or equal to 7? Yes. So it is true for that inequality. So it has to be true for both. Now I'm going to prove that it's true for this inequality. So 3 times y, or 3 times 4, is greater than 4 times x, so I'll replace x with a negative 3, plus 12. Okay, let's simplify. 3 times 4 is 12. Is greater than 4 times negative 3 is negative 12, plus 12 is 0. Is 12 greater than 0? Yes. So it's true for both inequalities. Okay, at this point, let's pause, and I want you to prove that 3, 3 is not a solution. So it's not going to be a solution for one of the two inequalities. So you'll plug this in for x and this in for y, and it shouldn't work for one of the inequalities. So I'm going to pause. You should pause too. Okay, and this is what our work should look like. I plugged in 3, 3 for x and y, and for the first inequality, 3 is less than or equal to 1. Is that true? No, it's false. So since this point is not true for this inequality, it's not true for the system. Just for fun, I also plugged it into the other inequality to show you this one's also false. So both of them are false statements, but only one has to be false in order for the whole thing to be false. Right, we were talking about the point 3, 3, so let's look at what that looks like graphically. So here's my origin, 1, 2, 3, 1, 2, 3. Is that in the double shaded region? No, so it's not a solution. Let's go back and look at this point graphically. Negative 3, 4. So here's my origin, 1, 2, 3, 1, 2, 3, 4. Is that point in the double shaded region? Yes. So that's why this one is a solution. It's in my double shaded region. And this one is not a solution because it's not in the double shaded region. Now let's look at the point 0, 4. Is this point a solution? What do you think graphically? Does it look like it's in the double shaded region? This one's hard to tell because it's on the border. So let's prove it algebraically. X, y. So let's look at the first one. Y is less than or equal to negative x, so negative 0 plus 4. So is 4 less than or equal to 4? Yes, it's equal. So it is a solution to this inequality because it is on a solid line, which means equal. Let's check the other one. 3 times y, so 3 times 4, is greater than 4 times x, so 4 times 0, plus 12. 3 times 4 is 12, is greater than 12. Is 12 greater than 12? No, it's not. 12 is not greater than 12 because it's equal. Because it's on the dashed line, it's not equal. It is not a solution. So even though this point was true for this inequality, it's not true for this one. Okay. At this point, let's try number 3. It's really multiple choice. You have 2 inequalities that make a system, and we're going to check each point to see which is in the solution set. You can check your answers on the answer key that will be posted, and in the video we're going to move on to actually creating one of the graphs. Okay. So when you turn the page, just a little review when we were graphing one inequality, that when you have a less than sign, you'll have a dashed line and you'll shade below the line. When you have a less than or equal to, it'll be solid and shaded below. When you have a greater than, it will be dashed and shaded above. When you have greater than or equal to, it'll be solid and shaded above. Okay? So when we create one of these graphs, we're really just taking both inequalities and we're plotting them on the same coordinate plane. Okay, so my first inequality, y is less than 2x plus 2. So take a look at your symbol. What type of line will I have? This is going to be dashed because there's no equal sign. And then which way will I shade? Below the line. Now when I create the line, I create the same way I create a linear equation. Okay, I find points on my grid using slope and y-intercept, or I can go to Desmos.com. I'm going to go based off the slope and the y-intercept. So my slope, my m, is 2, and my y-intercept is 2. So I'm going to start at the 2 on the y-axis. Here's my positive 2. And then I have a slope of 2, or 2 over 1. So that means from this point I'm going to move up 2 and right 1. Right? That's up 2, right 1. From this point, up 2, right 1. Up 2, right 1. Up 2, right 1. Okay. Once you have a few points, you could go in the other direction by going down 2 and left 1 if you wanted to. You don't have to. Okay. Then find a ruler or straight edge of some sort to connect your points. Just be careful because this is going to be a dashed line, so you don't connect with a straight solid line. You're going to be dashing. So it should look like this. Okay, we're going to put arrows on both ends. And then remember, we're shading below. So when I shade, I do stripes. Like this. And I'm going to label the line with y is less than 2x plus 2. Okay. before I do the other one, if you would prefer to do your graph on Desmos, just a little review, if you go to desmos.com, over, you can type your equation y equals 2x plus 2, hit the gear, and then the table to get points to plot. So you could get your points that way. I think, I haven't tried this yet, let me type in y is less than 2x plus 2. Wow, it even does the shading and the dashed line for me. That's pretty cool. Okay, so, I don't know if you can see that, you could type it in and get your points this way as well. Oh, it doesn't show me the points with the less than sign. Okay, you'll have to do the equal sign to get the points. Okay. Now I want to do the second line. Okay, so my second line, my second line has a greater than or equal to symbol. So that means I'm going to have a solid line, and I will shade above. Okay, so I'm going to start, I'm going to write it down here so I can annotate it, negative x minus 1. Okay, so my slope is a negative 1. So that means negative 1 over 1. So that means down 1, right 1. And then my y-intercept is negative 1. So I'm going to start at the negative 1. I'm going to do this in another color. So start here at the negative 1. And then your slope is negative 1 over 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. Okay, once you follow the pattern, you really only need 3 points. But you can continue if you'd like. Now this is a solid line, so when you get your ruler or your straight edge, connect and you can do a solid line, get my arrows. I'm going to write the inequality on the end, and then I am shading above. So that means from the line I'm going to straighten my graph that way. Okay. Your last step is to label the intersection with a big S. So this whole double shaded region is considered your solution. So I'm going to draw a big S over here. S stands for solution. So any point in this double shaded region is considered a solution. Okay. Now sometimes, it wasn't written in this example, but sometimes they'll ask you if something is a solution. So let's pick the point like maybe 4, 2. Because that's 42 is my favorite number. So is 4, 2 a solution? Okay. So you would say, yes, 4, 2 is a solution because it's in the double shaded region. Is, let's say, 0, 2 a solution? 0, 2. Is that a solution? Is that in the double shaded region? No, that is not a solution, because it's on the dashed line. If I pick something on the solid line, let's say 1, negative 2, is that a solution? Yes, because it's on the solid line. So anything in the double shaded region or on a solid border would be considered a solution. Okay? So send us a message if you have any questions. You're going to finish example 5, and then the 2 on the next page. Submit your photos of your graphs, and you can check your answer key if you have any questions. Okay?